Hello everyone, welcome to yet another video. Today we're still in probability and we're looking at discrete random variables. So let's pull apart what those each of those things mean. So we'll start with random variables first. So what a random variable is that, like in normal algebra, you might have the letter x, little x, and x is equal to 2, or x can equal 5, or x can equal negative 1.63 pi. And so that's a variable. It can have different values. And in probability, we can have a random variable. So you can sort of see down the bottom there in green, number of haircuts per month. So if we track how many haircuts you get per month, that could be different depending on the month. So that's a variable, and it's a random variable because it can have different variables. And maybe a number of haircuts might not be random, but if we did the number of haircuts per month across a school, we ask every student, that would be a random number, and then that we could have a look at. So that's a random variable. Shoe size, if we asked a bunch of students what their shoe size was, that would be a random variable. Height of women in a workplace, they would all be random variables, and we can give those random variables a letter to represent them. So where in algebra we do lowercase ones, in probability we give uppercase, like capital X, capital Y, capital Z, etc., etc. So capitals for random variables. Now, what does discrete mean? Well, if you've done other statistics work, it's the same definition here, discrete versus continuous. So what discrete means is it can be counted. Okay, so it can only have a countable number of values. It's the opposite of a continuous variable. A continuous one, you can't count the different number of possible values that it could be. Okay, so let's have a think about, out of these three written in green, which ones are discrete and which ones are continuous. So number of haircuts per month, if you think about it, what are the possible answers that if you asked someone how many haircuts did you have this month, what are the possible answers? It would be 0, 1, 2, 3, 4. We can only get whole numbers, right? And so that's actually discrete. There's a countable number of values. So that there is a discrete random variable. How about shoe size? If you think about shoe size, what would people's answers be? It would be 7.5, 8, 8.5, 9. There's only a certain number. You can actually count the number of responses. So that is also a discrete random variable. How about if you ask someone's height, what could they say? Well, they could say 1.85. They could say 1.8653. They could say 1.865392. Can you see how there's an infinite number of actual possible responses? And usually when we're measuring something, that's usually a continuous random variable. Okay, so this is height of women. You can't sort of categorize each different response. Whereas number of haircuts per month, we can put into a table and say, is it 0? Is it 1? Is it 2? What is it? And same thing with shoe size. Is it 7.5? Is it 8? Is it 8.5? Etc. But with height of someone, is it 1.86? Is it 1.865? 1.866? Etc., etc. So that's height of, that would not be a discrete random variable. Okay, so we're just going to jump straight into an example, because the best way to sort of describe how this sort of all works is just through an example. So let's have a look at this. The probability a student completes their homework on any given day is 1/3. Create a probability distribution table where capital X is equal to the number of days homework is done over 3 days. Okay, so we're talking about 3 days here. Then find, we'll get to that later and we'll have a look at that. Okay. So what we're going to do to represent this is a tree diagram. So I'm just going to give myself a bit of space. So just remember, this third is the probability they complete their homework. All right. So I'm just going to give myself a bit of space. We're going to have a tree diagram. So let's open it up here. Okay, it's a tree diagram. So this one is where they do the homework, and there is where they don't do the homework. So I'm going to say N is where they don't do the homework. All right, could use dash H complement, whatever. Okay, and so and what's the sorry, I'll put the H. Homework, no homework, and I'll put the probabilities on the second, and then on the second day, there's the probability that they either do their homework or they don't do their homework. And then on the third day, they either do their homework or they don't do their homework. And so what we end up with is this tree diagram that looks something like this. That one splits into 2, homework, no homework, and that one splits into 2, like that. Splits into 2, like that, homework, no homework, homework, no homework. Okay, and I've already forgotten what I said. 1/3 is the probability that they complete their homework. So let's start putting some probabilities in here, right? So it's 1/3 that they do their homework, and it'll be 2/3 that they don't do. So it's more likely they don't do the homework. Right, naughty students. Okay. Right, and these go through. So it's on any given day. So the probability of doing homework is 1/3, 2/3. All of these 1/3, 2/3, 1/3, 2/3. Sorry, this is a bit boring watching me do this. But it's sort of good to sort of see how these things work. 2/3. And this will sort of help with binomial distributions later on as well. Okay, so I've got all my probabilities of all the sort of different things going on here. And what we're trying to do is look at the overall probability. So what I'm going to do is I'm going to put a dashed line down here, like we do with a tree diagram, and say, well, that's homework, homework, homework. So that's when the student does homework on all 3 days. This second outcome is homework, homework, not homework, homework, not homework, 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 not, homework, homework, not, homework, not, homework. Sounds weird. Sort of sounds listening to this, I think I'm going insane. So they're the 8 different outcomes. 1, 2, 3, 4, 5, 6, 7, 8. There's the 8 different outcomes. And let's have a think about what the probability that each of these happens. So let's do the top one, homework, homework, homework. It's 1/3 times 1/3 times 1/3. So the probability that that happens is 1/3 cubed. Probability of homework, homework, not homework is 1/3 squared times 2/3, I think, times 2/3. Yep. Okay. So I'm just making sure I'm getting that right. 1/3, 1/3, 2/3. Yep, that's right. Homework, not homework. Homework, not homework. I should just really be looking at how many H's there are, and that's 1/3 squared 2/3 again. Homework, not will be 1/3. That's a 3. 2/3 squared. Not homework, homework. So not is 2/3. And homework is 1/3 squared. Hope you see what I'm doing here, multiplying the fractions as I go through a path. You don't know. So if I'm just doing that path there, then that's 1/3 times 2/3 times 2/3. And that's how I ended up with 1/3 times that. So just in case you don't know what I'm doing there, just multiplying as I go through the branches. Not homework, not will be 2/3 squared 1/3. Stick with me here. You'll see why it sort of help explain what's going on with discrete random variables. Not is the same thing. There's 2 nots, so it's 2/3 squared 1/3. And not is 2/3 cubed. 2/3 times 2/3 times 2/3. Let's just write down what that's equal to. 1/3 cubed is 1/27. That one, everything's going to be over 27, so that's just going to be 2/27. That's going to be 2/27. That one there is going to be 4/27. So just calculating all these probabilities, multiplying them together, that's going to be 2/27. That one there is going to be 4/27. And is that right? Yep. And that one's going to be 4/27. And that one, 2 cubed, 8/27. Right. So that's the most likely one. 8/27. Right. So we've got all this garbage here, right? And so that's our tree diagram complete. So you can see the most likely one is that the student doesn't do their homework for 3 days consecutively. That's the most likely outcome there. So what we're going to do now, if we remember that capital X is the number of days homework is done over 3 days. And so what we're going to do now is we're going to do up a table and we're going to show each of these. So what we do for each of the different values of X, we're going to write down what's the probability that X equals X. You'll see what this looks like in a second. So what do we have? We can have X was the number of days. So it could be done, they could do 0 days of homework, could do 1 day, 2 days, or 3 days of homework. They're the only options here. Okay, so extend the boxes down a bit, like that. And just get rid of that. Oops, that's the whole line. Let's just draw another line through there. So what this table is, right? What this table is that we're saying, well, what's the probability that x is equal to 0? And we're going to put the answer in here. What's the probability that x equals 0? In other words, what's the probability that he does no homework? And then in here, what's the probability that he does 1 day of homework out of the 3, 2 days of homework and 3 days of homework? And we're going to put the answers down in there. So let's go and do that. What's the probability that he does no homework over the 3 days? So that's n, n, n. So that's that one down that bottom, and that's 8/27. So I'm writing 8/27 for 0 days that he does homework. Okay. Next one, let's do 1 day of homework. So which ones have got 1 day of homework? So we only want one H in there. So it's going to be this one, and this one here. So they're all my 3 outcomes where he does 1 day of homework. Did I get that right? Just checking. Yep. And so it's going to be 4/27 plus 4/27 plus 4/27. If I add those 3 all together, I get 12/27. Okay, so 12/27 is the chance that over the 3 days, the student does 1 day of homework. Okay, let's do 2 days of homework. I'll do this one in yellow. What do we want? 2 days of homework. So we want 2 H's. So that one. This is looking really messy now. I apologize for this. So we've got those, and so we've got 2/27 plus 2/27. That's 4/27 plus another 2/27. That's 6/27. 6/27. And 3 days, that one is easy. 3 days of homework, which is highly unlikely, is 1/27 up the top there. So 1/27. 27th, okay? And that is called our probability distribution table. It shows you quickly what is most likely to happen with that random variable, which the random variable, remember, is the number of days that a student does homework. We can see that the most likely happening here is that he does 1 day of homework, because that's got the highest probability of happening there with 12/27. Okay, and so that's called, that there is called your probability distribution table. Okay, and it can give us lots of valuable information. Now, a couple of things to tell you about a probability distribution table is that always those probabilities need to add up to 1. Okay, and so it's always a good check to have a look at that and make sure that all those numbers add up to 1. 8 plus 12 plus 6 plus 1 is equal to 27. So that's 27/27. So yep. So it's a good check. I've done all my maths correctly. That's all fine. And that's always the case. Those probabilities must add up to 1. That's one of our properties of a distribution table. Also, obviously, probabilities must be between 0 and 1. So that's the other thing that we need to make sure that a probability distribution table always has. So that's essentially what we needed to do for this question, create a probability distribution table. We just want to find probability that x is less than 3. So I'll just leave that. So firstly, probability that x is less than 3. Let's just finish this off. Probability x is less than 3. Okay, so which ones are less than 3? It'll be that one, and that one, and not that one. Okay, because 3 is equal to 3, not less than. And so all we need to do is add the probabilities. That's nice and easy. Just looking at the 3 different situations, adding those together. So that's 26/27. That's the probability that he doesn't do his homework for one of the days. Okay, so for 3. And lastly, the last question is equal to 1, less than 3. So probability less than 3. Okay, so now it's allowed to be, so it's x must be greater or equal to 1. So that goes from down, so I'll just get rid of those and show you what's in there, which ones we're doing. And so we're looking at x must be greater or equal to 1, so it's this one. It's not that one because it must be greater or equal to 1. It is that one there as well, but it can't be that one either because it's less than 3, not less than or equal to 3. So we just add up those two columns. So it's just simply 12 27ths plus 6 27ths. So that's 18 on 27, and I see a common factor of 9. So divide by 9, and I'll get 2/3. So the probability that the number of days that this student does homework between including 1 and less than 3 is 2/3. Hope that all makes sense. That's a bit about discrete random variables and how to set up a probability distribution table. See you in the next video.